Find the volume of the solid of revolution formed by rotating the region bounded by the curves y equal the cosine of pi x over 2 and y equals 0 for x is between 0 and 1. Rotate this about the y-axis. So if the graph isn't given to you, you have to figure out for yourself what it looks like. It's a cosine graph that has been stretched or compressed in the x direction. The factor that you multiply x by ends up being the multiplier that tells you what the new period is. The new period is the old period divided by that multiplying factor. In this case, I'm going to use the letter B. It's the multiplier of x. And so we have the old period of 2 pi, and then the multiplier here is pi over 2. And so it turns out then that the pi's cancel, and we have a period of 4. So you complete the cycle of you complete the period of cosine by the time you get to 4. We don't need that much. We just need the part that goes till 1. So cosine starts up at 1 on the y-axis. By the time you're at you move from 0, x equals 0 to x equals 1, you can plug a 1 in, you'll see that you'll have the cosine of pi over 2, and so that's going to be 0. So we just care about this part here. It does do the rest of it by the time you're done at 4, but we don't really need that. This is rotated about the y-axis. Okay, let's immediately try to figure out which method to choose. Let's first try disk method. Disk because there's no gap between your region and your axis. So when you do disk method, you draw a rectangle that is perpendicular to your axis, and that brings about the main issue that when you have a rectangle that is horizontal like this, it's going to be moved upward to create the to generate the volume, and so the main thing is that it's going to be in y. So you have to solve for x, which would involve some cosine inverse, and then you have to integrate that. So for that reason, disk method is out. Let's go with shell. We have to draw a rectangle that is parallel to the axis of rotation. Immediately attach it, and we need to find two things. We need to find the height of that rectangle and the radius. The radius is this distance that attaches the rectangle to the axis. Whenever the axis is the y-axis like this, then this distance off of the y-axis is called x. And we're going to be in x because this guy is a vertical rectangle that gets moved horizontally. And so this radius then would just be x. The height of the rectangle is just the distance up to the function, cosine of pi x over 2. So we have everything we need. We're ready to go plug into the formula for the volume using shells. 2 pi times the radius times the height integrated from a to b. So we're going to have 2 pi times x times the cosine of pi x over 2. We're going to go from 0 to 1. Alright, great. Let's go to the next slide and work out this problem. Notice that we have an x times a cosine. And so the x is treated like a polynomial, is a polynomial, and then the cosine is a trig. And so we're going to have to do integration by parts, but thankfully we have a shortcut because we have a polynomial times a trig, but a trig that you can easily integrate. And so let's go with the shortcut on the next slide. The shortcut says to take the derivative of the polynomial down to 0. And then it says take the integral of the cosine, or the other function, the same amount of times. When you integrate cosine of kx, what you end up getting is 1 over k sine of kx. It's like a chain rule in reverse, a little u substitution if you need it. And so we're going to get the reciprocal of the multiplier, which is 2 over pi. Now, the multiplier is pi over 2, so its reciprocal is 2 over pi. And then we'll get another 2 over pi, and we just have that the integral on sine kx would be, the same kind of 1 over k, but cosine has negative sine x, so we have to throw a negative in to balance out the negatives that's going to come from the derivative. Okay, great. So then what do? We multiply along diagonals, going down and to the right, starting from the top on the left, applying alternating signs, with the plus being the first one. And so immediately we have the antiderivative. It saves us a little bit of trouble. I mean, it's only integration by parts once, but here we have it, 2x times over pi times the sine of pi x over 2. This negative here and the negative here cancel, and we just get 4 over pi squared cosine of pi x over 2. We have to evaluate from 0 to 1. And so just put a 1 in and put a 0 in. Along the way, you definitely can simplify, but nothing wrong with just it helps you to find your mistake if you just sub them in. We know these 4 values. I even just cheated. I didn't write the sine of 0. It's 0. And then we have the cosine of 0. And so sine of pi over 2 is 1, and the cosine of pi over 2 is 0. Cosine of 0 is 1. So this guy zeroes out, and the sine of 0 zeroed out. Cosine of 0 is 1. Sine of pi over 2 is 1. So we get this 2 over pi from that part, and then the minus 4 over pi squared for that part. Don't forget the 2 pi on the outside, and we can simplify this slightly by factoring out a 2 and maybe multiplying the pi in. So if we factor out the 2, we already have the 2 pi out. We take a 2 out, we'd have 1 over pi minus 2 over pi squared. But then, so that's multiply this pi in. We have this 4 on the outside. Multiply the pi in, we get just 1 here. And then minus 2 over pi here. And then you could, I guess, anyway, we end up with this 4 minus 8 over pi for our answer. If you're a stickler about units, this is volume, so units cubed. Okay, great.